Hi everyone, it's Mrs. Sommer here to talk about lesson 603C, mole-to-mole conversions. So in this lesson, we'll be able to convert from moles of one substance to moles of another substance using a balanced chemical equation. While you're doing this lesson, make sure you have your periodic table and your conversion chart, or the map. So the map you can use either using Kami, or you can print it and use it that way. If you recall, balanced chemical equations is we balance the equations to represent the law of conservation of matter. Remember, matter cannot be created or destroyed, it is only rearranged. So to balance chemical equations, we change the coefficients to ensure that there are the same number of atoms on both sides of the equation. So what is stoichiometry? Stoichiometry is using conversion factors to answer a question. In chemistry, we use it as the relationship between amounts of substances in a chemical reaction. You have used these types of calculations all the time in your daily life. You just don't know it. In the first part of this video, or this lesson, we're going to talk about using a real-world example, something you're familiar with. So here's the scenario. RRHS is having a bake sale to raise money for new lab equipment. Mrs. Sommer, aka me, I'm asked to bake some of my custom sugar cookies. Given the ingredients she has, let's see how many batches I can make to donate. So here's my recipe. And yes, this is the actual recipe that I use for my custom sugar cookies. So 2 cups of white granulated sugar, 1 teaspoon vanilla extract, 3/4 cups of whole milk, 4 eggs, and 6 cups of white flour. So I have a ton of sugar, vanilla, milk, and flour. But I only have 6 eggs because you know what? My 8-year-old loves making scrambled eggs. I don't have enough eggs. So how many batches can I make given I have 6 eggs? Okay, so yes, this is stuff that I've actually made, my custom sugar cookies. So steps to solving a problem like this. You write your balanced equation. You set up your work in following the units. You identify useful conversions. You do the math, and then write the answers with the correct units. In the sugar cookie example, write a balanced equation. So what we're going to do is we have 2 cups of sugar plus 1 teaspoon vanilla plus 4 eggs plus 0.75 or 3/4 cup of milk plus 6 cups of flour equals 1 batch. So the step 2 is to set up your work to follow your units. So we're trying to go from the number of eggs to how many batches I can make. So using our balanced chemical equation, we write our givens go here, our units I want up here, and I'm pointing and you can't see that, givens go here, what I want up here, and what I want to get rid of down here. And so what it looks like is this. We have 6 eggs is what we're given. And then the batches over eggs. We haven't entered any of our conversion factors yet. This is just what we want to find out. Step 3 is to find useful conversions. So using this balanced chemical equation, we can set up a ratio of how many eggs to how many batches we use in one quote-unquote reaction. In chemistry terms, this is called a mole-to-mole ratio. A mole-to-mole ratio is just a conversion factor. It allows us to get from what we want or what we know to what we want. So given the balanced chemical equation, how many eggs, our reactant, do we need to make the batch of cookies product? So if we look here, 4 eggs equals 1 batch. So for our conversion factors can be 4 eggs over 1 batch or 1 batch over 4 eggs. This is our conversion factor. Step 4 is to do the math. In this question, Mrs. Sommer has a ton of eggs, or a ton of sugar, milk, vanilla, but only 6 eggs. How many batches can I make? So I can use, this is my conversion factor, or I can use this conversion factor. But look at what we set up in during step 2. We had 6 eggs, and we wanted our eggs on the bottom and our batches on top. So we have 1 batch per 4 eggs. So when you do that, 6 times 1 divided by 4, you get 1.5 batches.